Hello everyone. Today we are going to discuss about the t-test. In our last video, we had discussed about the z-test. Z-test and t-test both used for a same type of the problem. There is a very small difference in z-test and t-test. Let's understand that. In our last video, we had discussed that we use z-test when we know the population variance and when we have a sample size is greater than or equal to 30. So we use t-test when we don't know the population standard deviation or population variance. It means if in our data set or in a population standard deviation is not given and the sample size is less than 30, then we use the t-test. So where we use t-test? If we want to compare the sample mean with population mean. Let this is your data set and this is your sample, and if we want to compare that this sample is belong to this data set, so we can compare the mean of the sample and mean of this population. So same way, if we have a two data set and we want to compare that both data set are same or not, so in that case we can also use the t-test. And the condition would be standard deviation of population should not be given, and second condition is that n is less than 30, and we assume that population is normally distributed and all the samples observations are random and independent. It means z-test and t-test both are same. So if you want to understand what is the z-test, you can follow my z-test video. After that you can come back to the t-test, you will get some more details. So let's understand by one example here. Let's a LED manufacturer claim that average life a particular category of LED is 18,000 hours. A random sample of 16 was tested and mean and standard deviation of samples are 20,000 hours and 6,000 hours. Assume that life of LED is normally distributed. We need to test the manufacturer claim is correct or not at 1% significance level. So population mean, this is your population mean. So population mean is given here, and we know this is your sample mean. Sample mean is also given, and this is your sample standard deviation, this. And third one is your alpha. Alpha is your 1. It means 0.01. And total number of samples is 16. It means n is less than 30 and standard deviation is not given. So we can use the t-test. So formula of t-test is same as we use in z-test. X bar minus mu divided by s divided by root n. In z-test we use sigma, but here we are using the s. So x bar, it means samples mean 20,000 minus population mean is 18,000 divided by s means standard deviation of sample is your 6,000 divided by root 16. Root 16 is your n is equal to 16. So we will get 1.33. So this value we got by using the t-test. So now we have to verify this particular value. Now we have to compare this value with t value, which we will get by using this particular alpha. Alpha means critical value. So how we will get the t value corresponding to this critical value? So for that we would need the degree of freedom. So degree of freedom, we can get the total samples minus 1. Total samples is 16 minus 1. So degree of freedom df is equal to 15. Now we have to calculate the t value corresponding to alpha. Now first question is that this is your one tail test or a two tail test. So if the LED average life is greater than 18,000, our null hypothesis would be if mu is greater than or equal to 18,000. So we will accept the null hypothesis, otherwise we will reject the null hypothesis. Mu is less than 18,000. So manufacturer claiming that their average life of the LED is greater than or equal to 18,000. So we have to calculate the alternate hypothesis in only one direction. So we can use the one-tailed test. So now question comes that how we can calculate the t value corresponding to this alpha. So for that we will use the t table. So in t table we will get the t value corresponding to this 0.01 and degree of freedom is 15. So let's go to the t table, then we will verify what would be the value of t value corresponding to this alpha. So this is your t value. So our alpha is 0.01 and degree of freedom is 15. So now there are the two row y-axis, this is your x-axis. So in x-axis you can get the alpha value. Alpha value is your 0.01. This is your 0.01, this one, and degree of freedom is 15. This is your 15. So we can say that the value we are getting 2.602. So we are getting the t value corresponding to this alpha. Alpha is your for one tail test. You can see there are two things, one tail and two tail. So one tail, this is your 0.01 alpha. So we are getting 2.602. 2.602. Let's go back to our question. So alpha, so t value corresponding to this alpha, we are getting 2.602 and t test value is 1.33. If we plot here, so what would be the critical? This is your critical region, this your critical region, and this is your, and this region, it means it is not resides inside the critical region. So whatever the t value we are getting by using the test, that is not reside inside the critical region, it means we can accept the null hypothesis. So we will accept the null hypothesis. It means we can buy these particular LEDs. So by using that we can solve some real world problem by using the t test. I hope you will like my video. If you have any question or any query, you can mention in the comment section. Thank you very much for watching my video. Have a nice day.